Today we're starting a new unit, Unit 3, on parallel and perpendicular lines, and our first lesson is going to be on lines and angles. So what I want you to do is take your notes here, and then perhaps after you've taken your notes, come back and write your essential question. So first, as almost always, let's start off with some vocabulary. What kind of lines are coplanar and never intersect? Those, of course, are parallel lines. And of course, we know that it might look like this. And if we want to designate, the symbology to designate that these are parallel to each other is to put identical little arrows on them like that. Those are parallel lines. Okay, what if we have lines that are coplanar, not coplanar, not parallel, and do not intersect? Then those are called skew lines. And we'll look at some drawings that will give us an example of some skew lines here in just a minute. What about planes? Planes that do not intersect are parallel planes. And let's think about that like this. Suppose we've got a box, and of course these aren't really planes because planes go on infinitely in two directions, but if each of these surfaces of this box was a plane, then the parallel planes would be this top plane and the bottom plane, and of course the sides across from each other. Let's see. This plane here would be parallel to this plane here, and then the front and the back of the box, excuse me, those planes would be parallel as well. So you can have parallel lines and parallel planes. What if we have a line that intersects two or more coplanar lines? So coplanar line, oh, they don't have to be parallel, they're just in, these lines are in the same plane. So let's just draw us a couple of lines here. And as we said, they don't have to be parallel. So these two lines would eventually intersect if I kept going out there to the right. And so now we've got another line that intersects these two lines at distinct points. So here's that other line. What is that line right there? That's called a transversal. And a transversal is very special to us because it creates all kinds of special angles with special relationships. So let's talk some more about our lines and our transversal. So let's just label. Let me just, I'll use green here. So I'll just put some numbers in all these angles. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to use this diagram here to answer a few questions below. So looking at this question here, two angles that lie on the same side of the transversal. So if the transversal's red, of course we're talking about either the right side or the left side. Lie on the same side of the transversal and in corresponding positions are corresponding angles. Corresponding angles. So if we want to pick out a pair of corresponding angles, we know that, okay, all the angles that lie on the same side of the transversal would either be 2, 4, 6, or 8, or I could only pick 1, 3, 5, or 7 from the other side, but they have to be in corresponding positions, which means if one of the angles is below one of the blue lines, then the other angle has to be below the blue lines. So our corresponding angles, I'm just going to pick a couple of examples here. So let's pick on the left side of the transversal. Angle 1 and angle 5 would be corresponding. And if I pick a set on the right side of the transversal, what do you think? 4 and 8, 2 and 6? Yeah, there are plenty I could choose, but I'm just going to pick a couple of pair for each one. All right. What kind of angle? So if we have non-adjacent exterior angles, non-adjacent, we know now what adjacent angles mean, and they lie on opposite sides of the transversal, then we know How do I get this thing out of here? There we go. Those are alternate. And it says exterior. It could have said outside. Alternate exterior angles. So they're non-adjacent, means not right beside each other. They don't share a side, and they're outside. They're opposite sides of the transversal. So let's pick a couple of examples like we did. What if I pick angle 1? That's an exterior angle, right? Because it's on the outside of one of the lines. What is the angle that is an alternate exterior angle to angle 1? I hope you're thinking angle 8. And let me pick another one. I've only got one more set of these, right? And that would be angle 7 and angle 2. Those are my only two sets of alternate exterior angles. What if I have non-adjacent interior angles that are on opposite sides of the transversal? Of course, those would be alternate interior angles. And if I go back just a little bit and look at my picture here, I could use angle 3 and angle 6, right? Or I could pick angle 4 and angle 5 for my two sets of alternate interior angles. All right, now guys, if this isn't clicking with you, then be sure to check for some more examples in your textbook and practice this tonight. Or let's talk about it in class tomorrow. We've got one more set here, interior angles that lie on the same side. Well, let's draw our diagram again. We don't want to have to flip back to it. And I think I had that line coming up like that. Our transversal here was red. And 1, 2, 3, 4, 5, 6, 7, 8. So interior angles. So once we say interior, we know that restricts us to either angle 3, 4, 5, or 6 that lie on the same side of the transversal. Same side of the transversal. So those are called, strangely enough, same side interior. Going to be hard to fit that. Or consecutive interior angles. And of course my sets there would be angle 3 and angle 5, same side or consecutive, and angle 4 and angle 6. All right, so those are my special angle pairs that I need to learn very, very well. All right, let's go back here and look at some. We've got this prism here, and it's asking us to think of each surface of this prism as a plane. So let's try to do this. So that would mean each segment is actually a line instead of a segment. So if we're looking at line AG, I'll highlight that for you. Here's line AG. And we want a line parallel to that that contains point C. Here's point C right here. So what line would be parallel to that? I think that would have to be line CI, wouldn't it? Because remember, any three non-collinear points make a plane. So I could make a plane out of points A, G, and C, or A, G, and I, and then that would include the point C, and that would get me the parallel lines. Alrighty, how about perpendicular to AG? Perpendicular to AG. Oh, that's the one we just had. So here's AG again. But this time we want a line that's perpendicular and contains point B. Here's point B. So what line is going to be perpendicular to that? Well, it's going to be line AB, isn't it? Because there's our right angle. So that would be line AB. Alrighty. How about skew to AG? Remember, what does skew mean? Skew means those lines are not coplanar. they're not parallel, and they don't intersect. So here's AG again. And we want the skew line to contain point C. There's point C again. So what line would that be? It looks like it could be CB or it could be CD. I'm going to sketch in CD here because those two points C and D are not coplanar with A and G. So that's what I'm going to pick there for my line that is skew to AG and contains C. Name the plane that contains point C. Let's clean it up here again. Contains point C and appears to be parallel to plane AFL. Where is plane AFL? It's this plane over here on the side. Here's plane AFL because L is that point right there, F is right there. So I'm looking for the plane that contains point C and appears to be parallel, so I think it's going to have to be this plane right here, right? So I can pick any three letters on that plane. So I'm going to call this plane CDJ. All right. Sometimes it's very hard to visualize these planes when we only have we can't draw a plane that actually goes on and on, so we have to use our imagination just a little bit. So be sure to make yourself a note there if you need to talk about that some more in class. All right, we're going to talk about some postulates now, and this actually comes in section 3-5 of your textbook, but I felt like this was a really good place to talk about it. So here we go. Through a point, not on a line. So let's just stop right there and let's see what we got. So here's a line. Here's a point that's not on that line. Let's just call that point P. So far that's what we have. Through a point, not on a line. So here's our line. Here's our point not on the line. It says there is one and only one line parallel to the given line. So what that means is I can only, through this point, draw one line that is parallel to the given blue line. That's the parallel postulate. Only one line you can draw. If I give you a line and I stick a point somewhere, you can only draw one line through that point that is parallel to the original line I gave you. All right. Same kind of thing with perpendicular lines. If there is a line and a point not on the line. So here's our line again. Here's our point not on that line. There is exactly one line through this point right here that's perpendicular to this given line. And there it is right there. Only one of those lines I can draw through that point. Okay, let's practice a little bit back to our angle pairs that we get from a transversal. Let's use the figure over here on the right to answer these questions. List all pairs of corresponding angles. Well, you got to remember what corresponding angles are. So this, of course, would be our transversal. Sometimes you will find that colored pencils come in very, very handy when you're looking at parallel lines, or these aren't parallel lines, but lines and transversals and all that stuff. Okay, so corresponding angles. So remember, corresponding angles have to be on the same side of the transversal and in corresponding locations. So let's see, we got angle 1 and angle 5. We got angle 2 and angle 6. We got angle 4 and angle 8, and finally angle 3, and I don't need that comma there, angle 3 and angle 7. I think that's got them all. All right. I was just thinking, what if I decided to make my transversal one of the other lines right? What if I could do that, and then that's going to give me a lot more angle pairs. So I'm going to just leave it this way. We're just going to use, to answer these questions, this one scenario where the blue line is our transversal. All right, so let's list all pairs of alternate interior angles. All right, well, we've only got 4 interior angles, so that means we're only going to have 2 pairs. So we're going to have angle 2 and angle 8, right? Angle 3 and angle 5. I hope this is beginning to click. If not, you should probably pause your video here and work these next problems by yourself and then come back and check them. You do need to practice by yourself. All right, how about all pairs of alternate exterior angles? Let's pick angle 1. What is exterior and alternate? That would be angle 7, and then we've got angle 4 and angle 6. List all pairs of consecutive interior angles. Lost my picture there. Or same side. Remember, consecutive interior or same side interior angles. That's going to give us angle 2 and angle 5, angle 3 and angle 8. Now don't be confused and say angle 2 and angle 3. Those are not consecutive interior angles. What are angle 2 and angle 3? Well, they're a linear pair, aren't they? But because of how I defined my lines and my transversal, angles 2 and 3 would not be consecutive interior angles. Okay, here's some more examples. I would like you to stop right here and try to answer these on your own. I will work them and then you come back and check your answers. All right, take a moment here, check those answers. You see I made my 2 red lines, the lines that are intersected by the transversal. The transversal is purple, and those are the answers we get there. All right, we're going to do a proof now, so get ready. Here we go. In a proof, you will always be given some information and you will be asked to prove something. So in this case, we're given that the measure of angle AEC, so that's this angle right here. There's AEC, I'm going to mark that, equals the measure of angle DEB. So I'll give that the same marking. DEB is right there. So those 2 angles have the same measure, which means they're congruent. All right, and we're asked to prove that the measure of angle AEB, I'm going to mark that one here, AEB is congruent to the measure of DEC. So the red is what we're trying to prove. So just because I've marked it that way doesn't mean that we've proven that yet. So this is a kind of easy proof because you really just have to fill in the blanks. It won't be long before you'll just be given a statement or 2 and you've got to write down everything, but we'll start slow and take it easy. So what is our first statement? Our first statement in a proof is always going to be one of the given statements. So number 1 here, we're given right here that the measure of angle AEC equals the measure of angle DEB. And of course our reason for that is because that was given to us. That's what they told us. Okay, so look what they're saying here, the measure of angle AEB. So remember the red angle is angle AEB, and the measure of what equals the measure of angle AEC. Oh, so, and that's the angle addition postulate. So if I add the measure of angle AEB, I need to add this angle right here to it, don't I? The measure of angle BEC, then the sum of those 2 measures is going to give me the measure of angle AEC, right? Angle addition postulate. Okay, step 3, the measure of angle AEB, there we are with AEB again, plus the measure of angle BEC. Oh, look at these 2. Take note, these 2, this part and this part, it's the same thing. It repeats. But what I'm doing is look over here, it tells me I'm going to use the substitution property. So what can I substitute in for angle AEC? Well, I can substitute in the measure of angle DEB, right? Because those two are equal. And it really helped that they told me I was going to use the substitution property. All right, so there we go. So step number 4 says the measure of angle oh, I'm using the angle addition postulate again, so I got to do the same thing on this side that I did on this side. So why don't you take a minute and try to fill in that blank? If I look at angle DEC, that's the little red angle right here, and add to it the measure of angle BEC, then what do I get? I get the measure of angle BED. Which, you know what? I'm going to write that as DEB because that's the way it is right here. So remember, angle BED is the same angle as angle DEB, so I'm going to write it like I wrote it up above there. All right, and now I'm using the transitive property. The transitive property, let's think about that for a minute. Okay, so do me a favor here. Look at steps 3, statements 3 and 4. Okay, you see on the left side of statement 3, I have the sum of a quantity and it equals the measure of angle DEB. In statement number 4, I have the measures of two angles. The sum of those measures equals the measure of angle DEB. So what I have is two things in angles 3 and 4, two different quantities, and they both equal the measure of angle DEB. So what does the transitive property tell me? Well, it tells me that these two quantities on the left in statements 3 and 4 are actually equal to each other. That is the transitive property. So I'm just going to fill this in from statement 3, the measure of angle AEB plus the measure of angle BEC. I'm getting this right from statement 3 right there. And that's going to be equal to the left side of number 4, equals the measure of angle DEC plus the measure of angle BEC. So I just used the transitive property there like they told me to. And my last step is, look, exactly what I was trying to prove. But what you have to do is take just a moment and figure out how do you get from step 5 to step 6. So I want you to pause right here and think really hard about all those qualities, the properties of equality that you just learned, and figure out how you get from step 5 to step 6. What did we do? Oh, I see what we did. We subtracted the measure of angle BEC from both sides, right? If we subtract the measure of angle BEC from both sides, what we have left is the measure of angle AEB equals the measure of angle DEC. So that's going to be the subtraction property of equality. Okay, and I'm trying to remember if you had to make a flashcard last night with these properties of equality. I can't remember, honestly, if it was in last night's homework or tonight's, but if you did not learn those properties of equality, actually you probably learned them several years ago, but if you did not make a flashcard with those qualities, then you for sure need to stop and do that right now. All right, that's the end of your lesson. Your summary box is on the next page, and remember we didn't write our essential questions, so please go back and write those two things, and we'll see you next time.